Hello, this is Mr. Ensler, and this is the Chapter 6 Geometry Review. Hopefully going through this review helps you understand most of the things that we learned in Chapter 6, which is all about ratios, proportions, and similarity. So we started off Chapter 6 with talking about ratios, like these first four problems. And when you have a ratio, you usually want to be comparing the same units. So if we compare 15 units to 6 units, and if both of those are meters, well, actually the meters are just going to cancel out. So we have 15 over 6. So you just want to reduce that as much as possible. I can divide both of those by the same number, and you divide them both by 3. So then you get 5 over 2. And when you write a ratio, you can either write it as a fraction, you can write it with a colon in between, or if you really wanted to, you could write out 5 to 2. I usually write it as a fraction, but you can do whichever way looks good to you. Number 2, same kind of thing. We already have the same units, so those cancel out. 22 over 24, those both divide by 2, so we have 11 over 12. Number 3, you see we do not have the same units. Inches and feet, so we have to make the determination which one to keep and which one to change. I think it'd be easiest here to convert the 2 feet to inches rather than 14 inches to feet, because 14 inches as feet would be like 1 point something feet. I don't know exactly what that would be. So I know that 2 feet is 24 inches because 12 inches in 1 foot. So now the inches cancel out. We have 14 over 24. Divide those both by 2 and we get 7 over 12. You want to reduce it as much as you can, but in this case 7 over 12 is as reduced as it's going to get. And number 4, centimeters and meters. Okay, if you recall, there are 100 centimeters in 1 meter. So you could do this one either way. If you wanted to change the 500 centimeters to 5 meters over 2 meters, you could do that, and that would just simplify to 5 over 2. Or you could do the other way around. You could keep the 500 centimeters, and on the bottom, 2 meters is 200 centimeters. It works out the same way because these are just going to cancel to 5 halves either way. Alright. The next type of problems that we have are solving proportions. We've done a lot of this unit, and the way that I'm going to recommend doing this is to cross multiply and set equal. So on one side, I'll have 3 times x. On the other side of the equal sign, I'll have 14 times 2. And so that's going to be 28. And then you need to divide both sides by 3. Don't freak out if your answer doesn't come out evenly. We know often we get integer answers, but not every time. So, you can double check your work, but yeah, sometimes we're going to get a decimal. So here you get 9 1/3. Or if you listed it as 9.3 repeating, that would also be okay. What you don't want to do, you don't want to just say 9.3 and round there. There's no reason to round. Number 6, let's set this up the same way. 3x equals 10 times 5, which is 50. And then you divide both sides by 3. I think this is another one where it doesn't work out exactly evenly. Let me just type it in here. 50 divided by 3. Yeah, I get 16.6 repeating, or 16 2/3. Those are the same number. It's up to you just which way you want to write it. Number 7. Alright, same kind of thing here, except you notice one of our parts of the fraction has more than one thing in it, this x minus 4. So you might remember you have to put a parenthesis around that. So on one side you're going to have 2 times 8. On the other side you're going to have 5 times parentheses x minus 4. So that's 16 and 5x minus 20, because you got to distribute that 5. And now it's just a normal problem. We'll add 20 to both sides. Get 36, and we'll divide both sides by 5. So let me type that in here. 36 divided by 5. I get 7.2. I'm not rounding, it just comes out exactly to 7.2. Alright, same type of problem for number 8. We got to use parentheses. We have to use parentheses there. So on one side I'm going to have 6 times 10. On the other side I'm going to have 8 times x plus 1. So that's 60 and 8x plus 8. Then I would subtract 8 from both sides, and then divide by 8. Let me type that in. 52 divided by 8, you get 6.5. So there's our answer. Okay, got a couple more here. Here's another one. So I have 2 times 2x minus 3. You can put that on one side. And 1 times 6 can go on the other, which is just 6. And when I distribute, I'm going to get 4x minus 6, adding 6 to both sides. That makes 12. Divide by 4, and we get x equals 3. Alright, number 10. Number 10. Another one just like the others. 9 times 8 will be on one side. 10 times parentheses 3x plus 1 will be on the other. So that's 72. 30x plus 10. Then to get x by itself, we'll subtract 10 from both sides. And then divide by 30. 62 divided by 30 comes out to 2.06 with the 6 repeating. Or, if you wrote that as a simplified fraction, how many 30s go into 62? 2 30s go into 62 with 2 left over. So that'd be like 2 and 2/30ths, which would simplify into 2 and 1/15. So that would be one way of writing it. This way is also okay because we do have the repeating sign there. Alright, then we have the problems where we talk about similarity. And in this case, these two shapes, WXYZ and MNOP, are similar. We know that from the similar symbol that's right there. And the order that those are listed in tells us a lot. It tells us what angles match up with each other. If you really wanted, you could go through and match up to say that W and M are congruent. W and M. X and N. Y and O. And Z and P. And then you might be able to see how one of these shapes is just kind of the rotated version of the other one, if you can see where these match up. So, first question, find the scale factor from WXYZ to MNOP. Now, the order that that's in is important. When we find the scale factor, you have to do it in the order listed. So we're going to put something from WXYZ on top, something from MNOP on bottom. And what you want to do is you just want to compare a set of corresponding sides, two sides where you know both of them. So for instance, I know Y goes with 10. Those two sides go together. They're not the same size, but they correspond. 12 goes with X. 8 goes with 10, and this 12 goes with, I don't know what this side is. So 8 and 10 would be the one to use because we know both of those. So the scale factor would be 8 over 10, and you want to reduce that to 4/5. Now, I would actually use that scale factor of 4 to 5 to find the next few answers. Let me show you what I mean. So the scale factor from the first shape to the second shape is 4 to 5. If I want to find X, X is in the second shape, and X corresponds with 12. They're not congruent, they're not the same, but they're proportionate to each other. So 4 to 5 equals 12 to X. Because you want to go in the exact same order that we did up here if you're going to use the same scale factor. Now that you have that set up, it's just a matter of cross multiplying. So we have 4x equals 5 times 12 is 60. Divide, and we realize that x equals 15. Let me use 4 to 5 again when we find y. So y is this side on the left, and it corresponds with 10. So y and 10. So 4/5 equals y over 10. Alright, and so that's 40 equals 5y. Divide both sides by 5, and you realize that y equals 8. Alright, I'll use it again to find z. 4/5 equals, alright, where is z? Z is right here. Oh, this one's going to be a little bit different. Z is an angle, and we actually already talked about how the angles are congruent. I already know that this angle right here is congruent to this angle right here. So they're the same. So there's actually no calculation to be done. You don't want to set up a proportion if you're finding an angle. It's just going to be congruent. So Z equals 135. That's kind of one of the things you've got to remember about these similar shapes, is that the sides are not the same sizes usually. They're in proportion with each other. They form equal ratios like we've been setting up, but they're not the same size. They're not congruent. Angles, however, are congruent, even though the shapes are different sizes. Alright, find the perimeter of WXYZ. Alright, well, now that I know that y equals 8, I can simply just add up all of the sides, right? You can, or if you want to use the official formula, 2 times 12 plus 2 times 8. So that's 24 and 16, so 40 is the perimeter. You could also just add up all the sides, right? 8 plus 12 is 20, 8 plus 12 is 20, add them together, you get 40. Find the perimeter of the other one, MNOP. Well, we know that x is 15, and since this shape is similar, it's also going to have the other side be 15. So add up all of those. You got 2 10s, which is 20, you got 2 15s, which is 30, and so 50.
Devin, me, sir, please go to students.
And that should make sense, because look what happens if you put those in a ratio with each other. 40 over 50, you reduce that, you reduce 40 over 50, and you get 4/5, which is our scale factor. One of the things that we learned is that if shapes are similar, their sides form equal ratios, but so do their perimeters. Alright, here's another set of problems, very similar. Alright, these two shapes are similar. Find the scale factor of BCDE to WXYZ. Alright, so we want to compare two sides that are corresponding. So, for instance, I might compare 6 and 4. Now, how do I know that those are corresponding? Well, visually, I could say, well, in both shapes I have two parallel sides. I'm going to compare the shorter parallel side to the other shorter parallel side. And so we have 4 over 6. Another way that you could figure out that those sides go together is this side 4 is BC. And BC is the first two letters. So take the first two letters of the other one, WX, and that's how you tell how they go together. So there's a visual way and kind of a analytical data using way. Alright, let's reduce that. 4 over 6 equals 2/3. And we went in the right order from BCDE first to WXYZ on bottom. So there is our scale factor, 2 to 3. I'm going to use that to figure out the rest of these numbers. So I have to go in order from top to bottom, kind of the order it's in. So find XY. XY is right here. And so that's going to correspond with CD. You might be able to just see that, or again, if you look up at the similarity statement, XY are the two letters in the middle, CD are the two letters in the middle. So 2/3 is going to equal 3 over my unknown value, XY. You can just put a single letter in there if you want. So then cross multiply, 2 times XY equals 3 times 3 is 9. Divide, and XY equals 4.5. Alright, find YZ. Again, I'm going to use 2 over 3, my scale factor. And where is YZ? Okay, YZ is here. So that's going to compare with ED. Those are both kind of the longer parallel sides. Or, if you match them up, YZ is the last two letters, and DE is the last two letters. So you know those go together. So it's going to be 2/3 equals 6 over yz. I don't know what it is. I'll just call it yz. You could call it x or a letter if you want. So 2yz equals 3 times 6 is 18. Divide that, and we know yz equals 9. Alright, next one. Find the measure of angle C. Where is angle C? Angle C is right here. And what angle does C match up with? Well, if I look at my diagram, C is the second letter, and X is the second letter. So, angle C matches up with angle X. Oh, angle X is 117, so therefore, the measure of angle C is also 117. And then the last one of these, find the perimeter of WXYZ. So that means I need to figure out all of these sides. So we already figured out that YX, or XY, is 4.5. And we know this side's also 4.5 because it tells us those are congruent. And we also figured out that YZ is 9. Okay, so you could just add up all four of those, right? 4.5 plus 4.5 plus 9 plus 6. So the 4.5's together equal 9. 9 and 9 makes 18, plus 6 is 24. Alright, the next set of problems asks us to find if the triangles are similar and tell us how. And we kind of know 4 ways to tell if triangles are similar. One is just the definition of similarity, which says that all 3 sets of sides have to be similar, and all 3 sets of angles are congruent. So, like in number 22, you can see that we have all 3 sets of angles congruent, and if you compare the side lengths, let's say I do 3 over 6, that equals 1/2, 5 over 10, that also equals 1/2, 4 over 8, that also equals 1/2. So this was the definition of similarity. So we need to write a similarity statement. I'll say triangle ABC is similar to, we want to make sure they match up, so ABC and FDE. So for this one, you could say just by definition of similarity, because that was our definition of all the angles are congruent and all of the sides are proportionate. But we did learn a few shortcuts along the way. We learned AA similarity, so if even just 2 angles are the same, then they're similar. So that's what I'm going to say. By AA similarity. Make sure you put the word similarity after it. Like I said, you could have also said definition of similarity, or you could have said one of our other rules. We have a couple other rules. We have SSS similarity, which says that even if you don't know anything about the angles, if just the 3 sides are in proportion, that's enough, even if you don't know anything about the angles. That'd be SSS similarity. So let's apply that to number 23. Let's look at what we have here. Do we have any angles that are congruent? Well, these 2 are congruent, these 2 are congruent, but we want angles that are congruent from one to the next. Well, let's check their proportions. So 5 over 6, 5 over 6, and 3 over 4. Are all 3 of these the same? No. So it says to give an explanation, tell how you know. Sides don't have equal ratios. Alright, number 24. So we don't know anything about the sides in number 24. We only know things about the angles. Let's figure out what all these angles are. So angle C right here, what I'm going to do is I'm going to add 92 plus 57. 92 plus 57 is 149. And then we're going to subtract that from 180. And we get 31 degrees. So this angle is 31 degrees. Alright, do we have any things that are congruent, any angles that are congruent? Well, this 92 degrees, this 92 degrees, and I don't know if any of the other ones will work. Let's check out this one right here. So add 92 and 41, and I get 133. That's not what that angle is. I have to subtract that from 180. and I get 47 degrees. So no, I don't have anything else matching up between these, so my answer is no. These are not similar, and it's because not all three angles are congruent. If they were similar, all three sets of angles would be congruent. Alright, number 25. Let's see here. Well, they don't give us any specific measurements or any specific angles. I guess they tell us that these angles are both 90, so we know that. But we're going to have to use a little bit of our creativity, a little bit of what we've learned in the past. Looking at the second triangle here, this is an isosceles triangle. I know that because these two sides are congruent. So therefore, what we know is that these two angles are going to be congruent. I don't know, at least not yet, if these two angles will be the same as these ones. I don't know that. But I do know that these two angles are congruent. Well, let's think about that for a moment. If this is a 90-degree angle and these two are the same, these would have to both be 45 and 45. And we have a similar situation over here. If this is 90, then these also have to be 45 and 45. So look at that. Even though we don't know exactly how long any of the sides are, we have at least two angles from one triangle that are congruent to two angles in another. And so by angle similarity, we can say that triangle ABC is similar to, alright, now I got to match this up in a good order, ABC. Well, as long as I put angle F last, I think it'll work. So how about triangle EDF? Alright, number 26. Okay, this is where we need to think about this as we have one big triangle and we have one small triangle that's inside it. And they share this angle right here. By the reflexive property, they both have angle S as congruent. And the fact that these are parallel lines tells us that these two angles, for instance, would be congruent because they're corresponding. It's our old situation of two parallel lines cut by a transversal. Well, these angles here and here are corresponding, and they're going to be congruent to each other. So, yes, these are congruent. And the ultimate reason is by angle-angle similarity. If you wanted to give some angles, some reasons before that, this would be by the reflexive property. And these are congruent by the corresponding angles postulate. Alright, number 27. Okay, this is where we use our last similarity theorem that we learned, which is the SAS similarity. It says if there is one angle that's congruent from one triangle to the next, and if the sides surrounding it are not congruent but they're similar, then it forms a similar triangle. So how to figure that out is we need to compare 28 and 16. And we also need to compare 21 and 12. We need to figure out, are those going to form the same ratio? So 28 over 16, those both divide by 4, and so we get 7/4. How about these ones? These ones both divide by 3. If I divide those both by 3, we get 7/4. Hey, look at that. The two sets of sides have equal ratios, and the angle in the middle is congruent, so this is what we call SAS, side angle side, similarity. So I'll say triangle RTS is similar to triangle XZY. Okay. The very last lesson that we had talked about a few theorems, and one of them was that if a triangle is bisected at one angle, it's going to split up the four segments that you have there proportionately. And so one way that you could form a proportion out of this is to say 12 over 8 equals 9 over x. There are other ways also, like we talked about in class, but you just got to choose one way and go with it. So then by cross multiplying, we'll have 12x equals 8 times 9. So 12x equals 72. And then we want to divide 72 by 12, which comes out evenly to 6. So 6 is our answer. It would have also worked if you wanted to say 12 over 9 equals 8 over x. Or you could have done either of these ways flipped around. You could have done 8 over 12 equals x over 9, or 9 over 12 equals x over 8. All of those ways of setting it up would still get you this answer of x equals 6. So like I always say, if you have another way of doing it, if you get the right answer and you show your work, that's fine with me. Here's another one, using that same concept. This is an angle bisector, and so you just want to set up a proportion. Maybe this one will do 3 over 5 equals 6 over x. And so then cross multiplying, I'll get 3x equals 30, x equals 10. If you wanted, you could have also set it up as 5 over x equals 3 over 6. You're going to get the same thing, because when you cross multiply, you'll get 30 and you'll get 3x, which is the exact same situation we had over here. So either way, you get x equals 10. All right. Here we have some more solving problems. This is just kind of a continuation of what we did before. So looking at number 30, this also relates to that last lesson, 6.6, that we did, where if you have 3 parallel lines cut by 2 transversals, what you'll have is you'll have 4 segments. So my segments are x, 10, 6, and 8, and those form a proportion. There's a couple different ways you could set it up. You could do x over 10 equals 6 over 8. You could do x over 6 equals 10 over 8. You could flip those upside down and do 6 over x equals 8 over 10, or 10 over x equals 8 over 6. You could set it up any one of these 4 ways and get it correct. Because the key is, no matter which way you set it up, when you cross multiply these, they're all going to say 8x on one side and 60 on the other. No matter which of these 4 ways you set it up, this will be your next step. And so then you just divide by 8. 60 divided by 8 is 7.5. So it forms a proportion, these 4 sides, and it's kind of up to you how exactly you want to set it up. Here's another one, same idea. Because these 3 angles are all congruent, by corresponding angles converse theorem, that means these are all parallel. So this is the same situation. The x, the 9, the 3, the 3.5 are all going to form a proportion. I'm going to do x over 9 equals 3 over 3.5. So then I'll have 3.5x equals 27. We'll divide both sides by 3.5, so 27 divided by 3.5. Ooh, that does not come out evenly. I get like 7.71. I wonder if it comes out as a fraction. Let me press second fraction decimal. And yeah, you get 7 5/7. How would you have gotten that without using the calculator? Well, 27 divided by 3.5, what I would do is I would times both top and bottom by 2, so I'd get 54 over 7. And then how many 7s go into 54? 7, which makes 49, and so there'd be 5 left over. If you rounded it to 7.7, I know that's what the answer key says, x equals approximately 7.7, that'd be okay. I just like trying to find the exact answer when I can. Alright, we had another theorem, it was called the triangle proportionality theorem, which says that if you have a triangle and a line cuts through that triangle and is parallel to one side of the triangle, if these two lines are parallel, then the four parts, the four segments, will be split up proportionally. We can set up a proportion. Alright, so are these parallel? Well, they tell us that this angle is 70 and this angle is 110, so together they're 180. Well, that's an example of consecutive interior angles, and consecutive interior angles add up to 180. So, long story short, yes, these lines are parallel, and these four values, 6, 14, x, and 9, can form a proportion. And you can set up that proportion in a number of different ways. I'll just do 14 over 6 equals x over 9. Then I'll cross multiply, and we'll get 6x equals 9 times 14. 9 times 14 is 126. And then divide 126 divided by 6, and you get 21 as your answer. Number 33 is set up very similarly. Notice that 60 and 120 add up to 180. So again, that's telling you these lines are parallel. Maybe this one I'll set up a little bit differently. Maybe I'll do x over 4 equals 10 over 12. And so cross multiply, we get 12x equals 40. Divide 40 divided by 12, and that comes out to 3 1/3, or 3.3 repeating. Number 34, this is a lot like 30 and 31. You see that we have three parallel lines. You understand how these lines are parallel because they all have the same angle here. So again, just set up a proportion. A bunch of different ways you could do that. I'll do 2 over x equals 3 over 3.5. You just want to be consistent. If I start with 2 and then go to x, on the next one I need to start with 3 and then go to 3.5. So cross multiplying here, 3 times x is 3x. 2 times 3.5 is 7. So divide both by 3, and there's a few different ways you could give your answer. X equals 7/3, or 2 1/3, or 2.3 repeating. That would also be fine. I'd probably go with the 2 1/3. Number 35, same kind of situation. We got three angles that are the same here. That means that these three lines are all parallel. So set up a proportion. How about x over 51 equals 36 over 54? If you were thinking you'd rather do x over 36 equals 51 over 54, that will work just the same, because look what happens next. We cross multiply. 54 times x, that's what you would do in this case also, equals 36 times 51. So 36 times 51 is 1,836. So now we just need to divide that by 54, and it equals 34 exactly. Alright, number 36. This is like the theorem that we saw before. We have one angle that is bisector of the triangle, so it takes the four segments and it splits them up. The issue is we don't have a name for this segment right here, and we need to have something for it. Well, I know this is x, so, and the whole thing is 28. So to get this, you would just do 28 minus x. So that's what we're going to call that, 28 minus x. Now you can set up your proportion. I'm going to do 8 over 28 minus x equals 24 over x. So when you set up one of these proportions, ideally you set it up with the individual four segments and not the whole length. Alright, cross multiply, we get 8x equals 24 times the quantity 28 minus x. So I'll definitely need to distribute there. 24 times 28 is 672. And I also need to distribute the 24 to the minus x, so that'll be just minus 24x. Then I'm going to I'll add 24x. How about? I'll add 24x, and that equals 32x. That's going to equal 672. So now divide 672 divided by 32, and I get 21. So my answer is 21. Alright, we're on the very last problem already. This one has a triangle with one angle that is bisected. So that means it's going to split each of the four segments proportionately. Again, we need to be able to put something right here. I know the total length is 33, and this is x. So if you knew what x was, if you wanted to find this, you would just do 33 minus whatever that is. So that's what we're going to put in for that side, 33 minus x. Alright, now we have our four segments. I'm going to do 45 over x equals 54 over 33 minus x. So cross multiply. 54x equals 45 times parentheses 33 minus x. Need to do some distributing there. 45 times 33, I get 1,485. And I also need to distribute to the minus x, so that's going to be minus 45x. So then I will add 45x to both sides. So you add those together and you actually get 99x. So divide 1485 divided by 99. Oh, it comes out evenly. X equals 15. So there is a summary of what we have learned in Chapter 6, talking about similar shapes, ratios, and proportions. Hope that helps.